Hello, this is Sterling Series again. We continue our discussion on the complex nature of the computer instructions. We already talked about coding and we also talked about how the computer executes instructions. So today we continue by discussing the complex nature of the computer instructions. See, we normally say that computer cannot think, but how do they do surgeries and also do some complicated tasks? Yes, computers cannot think. They follow instructions. That's a clear fact. When you take a dog, for instance, a dog can think, but they are not that intelligent because they are not human beings. You can improve on the way the dog does things by training it. In the same way, we can also train computers to do some strange things which one would tend to believe that it thinks. So we've been watching on our television, or we watched on our television before, seeing a dog going to the market to buy things because it has been trained. But the fact is that it is still limited in its thinking. So in the same way, the computers can be trained and the computers will be limited in its thinking. In actual fact, it doesn't think, so it will be limited because it does not think. Some complex instructions that are common with everyday life have also been written down and can be called upon by programs and executed all the time. The computers are made to execute this set of different instructions when needed in addition to its simple instructions. So in the same way, we say computers can be trained because they can execute complex instructions. When I started programming, for instance, I used to code sorting, but now you can simply call a sort function and it will do the sorting for you. In Python, for instance, with Python you can also evaluate sets, union of sets, a subset of sets, and there are instructions for that. There's also another function in Python called lambda that you can use to evaluate quadratic expressions. So all these things are becoming easy and easy because the instructions that are routine have been done by somebody and kept there that you can always go to. So, but still, this does not mean that the computer thinks. This set of instructions are very complex, and one tends to believe that the computer thinks. The complex nature of instructions are the basis of AI, which is called artificial intelligence. We have the discussions going on general artificial intelligence and specific artificial intelligence, because artificial intelligence are more or less directed towards performing certain tasks in a particular area and not general. So, for instance, you can have a robot doing a surgery, but that same robot may not be able to drive a car. So, there's this discussion going on about general artificial intelligence and specific artificial intelligence. So, when you instruct a computer or a robot to cut a plate for a car, for instance, you see it will come back to you and ask you which particular model of the car you are asking for. So if you specify the model, then the instructions it will go to the set of instructions that is related to that model, and then it will go ahead and perform those instructions. So that set of instruction is already there. So the instructions are already there, and the computer will go to that set of instructions and execute them. The instructions will have all the necessary dimensions related to that door. But because of the speed of the computer, you not notice it. You think the computer is like a human being, but that's not the case. But one fact we should also note this fact that the accuracy of the computer is very very high. So, and let's take note of this. From our discussion, we try to look at coding, and if we come to this stage, we want to kind of run through all that we've discussed. So let's take note of these. Instructions given to the computer to perform a specific task is what is called coding. The instruction you give to the computer should be in a language that the computer understands. The computer understands language of ones and zeros. And then you need a system that can convert your instruction to the ones and zeros. This is what we call the programming languages or the coding languages. With the help of the coding languages, we are able to give instruction to the computer and get an output that we understand. Like in our previous video, we said 3 plus 4 is presented as 7, which we understand, and it's not in ones and zeros. In actual fact, the computer will present the result as 111, which is the binary representation of 7. But with the help of the compiler or the interpreter, we get the result as 7 that we understand. So if you like this video, kindly click on the subscribe button, and also you can click on the bell icon to get notified anytime we upload a new video. Thank you very much.